Hi, this is Maggie. In this video we're going to talk about multi-dimensional lists. We call a list multi-dimensional if its elements are also lists. So a list of lists is a two-dimensional list, and a list of lists is a three-dimensional list. The dimensions come in the way we visualize lists. We visualize a two-dimensional list as a table and a three-dimensional list as a cube. We'll program an example with a two-dimensional list. This program shell has an event loop that processes a quit event and processes a mouse button up event by pulling the XY coordinates out of the event object. After processing events, the program blits the background to the screen and flips the display. It therefore does absolutely nothing visible to the user. What we're going to do is store the XY coordinates of the click in a two-dimensional list. Imagine the user manages to click at coordinates 1010, 2020, and 3030. Then we might think of this information as being in a table of XY coordinates, with each row being a set of coordinates and the first column being the X coordinate and the second column being the Y coordinate. I'm going to annotate a variable called coordinates of type list. Now, down in events, I'm going to add to the mouse button up processing by packing the XY coordinate into a list and appending that to my list. My list, if the user clicked at X10, Y10, would then look like open bracket, 10, comma, 10, close bracket, close bracket. And then once the user clicks again at X20, Y20, it would look like open bracket, 10, comma, 10, close bracket, comma, open bracket, 20, comma, 20, close bracket, close bracket. After we process events, I'll loop through the coordinates in the list and blit the Van Gogh image from the National Archives to the screen at each coordinate. Therefore, each time through the loop, the background will be blit to the screen, erasing all of the images, and then the images will be redrawn. This might seem a little strange, but it's the way a game works, because generally we're blitting images representing sprites that are moving around. Our list keeps track of the location of all of the images for us. If we click and add a location the next time the images are blit, we see the new image along with all the old ones. Now let's write the drawing code. We're going to loop through our outer list. So I'll annotate a variable I, and initialize it to 0, and then while I less than len coordinates, and then I plus equals 1 inside the loop. And inside the loop, I'll access coordinates sub I sub 0 for the X coordinate, and coordinates sub I sub 1 for the Y coordinate. The first index, I, gives me the first element of the list, which is a sublist with two elements, an X coordinate and a Y coordinate. The second index gives me a specific coordinate, 0 for X, 1 for Y. Let's run the program. Now, just for fun, let's give each image a little bit of movement. After we've processed events, but before we draw to the screen, we'll offset each coordinate by 1/10 of a pixel. I can do this within the blitting loop. I'll index into the list of coordinates using I, then add 0.1 to the x coordinate and store it back in x. So coordinate sub I sub 0 plus equal 0.1. And I'll do the same with y, coordinates sub I sub 1 plus equal 0.1. They'll move off screen, making room for other images. There's a little bit of fun in this example, but it's very common to store data in a multi-dimensional list. You might consider enhancing this program by loading more than one image and then adding another column to the table, one that stores the reference to an image. You could randomly select an image to go with each click, or assign them based on location of the coordinate or some other criteria. Then enhance the loop to blit the correct image for each click. You might also write your own program that stores names, addresses, and phone numbers as 3 elements of lists within a list of contacts, and then loops through and prints the information for each contact. When you can write these programs, you're ready to move on.